Okay, welcome students to video class 37, and in this video we are going to continue our discussion on Nyquist stability criterion, and let us mark this as this one is the part 4. Okay, this is part 4. Now here also we are going to do a problem. The question is, using Nyquist criterion, investigate the closed stability of the system whose open loop transfer function is given this. Now in the first two videos we were discussing about the theory behind this Nyquist plot and obtaining the Nyquist plot and applying the Nyquist criterion, and not only that, we also studied about the principle of argument. So this actually forms the basis of this Nyquist stability, the ascertaining of stability using the Nyquist plot. Okay. Now, in the last video, we have seen some examples, and in those two examples, we have considered a system, a stable system, right? So it's quite easy and to do with a stable system. So far, we haven't considered an unstable system. Now, here is a case. Here is a different case, and not only that, previously I have done. In magnitude angle form, I have tried to draw the Nyquist plot, Nyquist plot by having the magnitude angle form. But this time I'm going to use a different method, and I recommend to follow this method throughout the problem. So why I followed the other one is that is the theory behind, just to make you a feel of the theory behind it. That's all. And that is useful only if you draw that in a polar plot, okay, on a polar graph. So I told you, because if you are asked to draw it in a polar graph, then you need to draw like that. And if time permits, I will explain what is this polar plot. Polar plot is just like a like a graph sheet. It's like a graph. It's a graph paper, similar to our normal graph paper. Okay, so I will show you later on when time permits. Now normally the questions will be asked to plot the Nyquist plot, so you don't have to worry about to worry about drawing the Nyquist plot in a polar plot, okay, or a polar graph sheet. Now you can use your blank paper for this Nyquist criterion. Now if you want to use that, I think the suitable method, the method which I discussed earlier is not suitable. So we will have a slight change. That's all. So what we did was, the first step. Okay, let us move on to the problem. What is your step one? Step one is to identify right half poles, right? Identify the right half open loop poles, right? Now we can see that when you factorize this one pole, you will be seeing that this is at minus 0.5, that is left half pole, and another pole you can see that it is at 2, so this is a right half pole. So you got the answer, the first one, as p plus is equal to 1. So do remember our Nyquist criterion equation is z plus minus p plus. So we got the answer for p plus directly from the GSHS. Now what's your step 2? Now in your step 2, what you need to do is put s is equal to j omega to get your f of j omega, which is nothing but g of j omega into h of j omega, right? H of j omega, which is equal to k times s plus j omega plus 1, right? J omega plus 1 divided by j omega plus 0.5 into j omega minus 2. Okay. Now for the meantime, I'm taking this k to be, assume that let us consider this k to be equal to 1.25. okay, k to be 1.25. okay, so if k is 1.25, this equation can be written as 1.25 into 1 plus j omega divided by 0.5 plus j omega, right, into minus 2 plus j omega. Okay, so in the last sessions, what we did was we just take or we will convert this into magnitude angle form. Okay, angle form. Okay, that I did purposefully because that is to show you this is how you need to draw. You need to proceed if you are using polar graph sheet. That's a special type of graph sheet which I will be telling you later if time permits. Normally the question is not asked in that way. You will be simply asked to this will be the question using Nyquist criterion. So you can just draw it on a blank paper. So in order to plot that in a blank paper, this representation is not enough. So you need to represent, for that you need to represent this in the form of a plus jb. That is, what is the meaning of this? Separating the given function f of j omega into real and imaginary. Okay, now how will you convert this into real and imaginary? What we do is we multiply and divide by the conjugates of the denominator factors, right? So that will be equal to 1.25 into 1 plus j omega, right, into 1 plus j omega into 0.5 minus j omega into minus 2 minus j omega. These are the conjugates of these denominator divided by 0.5 plus j omega into 0.5 minus j omega, right? Then you have minus 2 plus j omega into minus 2 minus j omega. So this is of the form a plus jb into a minus jb. So we know that the result is going to be 1.25 into 1 plus j omega into 0.5 minus j omega, right, minus 2 minus j omega divided by, what is this? This will be 0.5 square, or which is 0.25 plus omega square, isn't it? A plus jb into a minus jb is a square plus b square. So this is this is it. So this will be equal to 4 plus omega square. So you'll be getting this. Now what is what next is you need to break this brackets and separate it into imaginary and real term, and you will get your f of j omega as f of j omega equals, okay, so you'll be getting like this, okay, is equal to minus 1.25 into 1 plus 2.5 omega square divided by omega square plus 0.25 into omega square plus 4 minus 1.25 j omega into omega square minus 0.5 divided by omega square plus 0.25 into omega square plus 4. Okay, so you need to do like this. Do remember the difference between this step which we have done earlier is just we have represented it in polar form. Instead of that, or you will call this as a Eulerian form, right? And instead of that, we represent that in a rectangular or a Cartesian representation, and that is what is called as rectangular or Cartesian representation is a plus jb. Okay, so represent your f of j omega into a plus jb. The why we are doing is we are just doing it because to plot in a plain paper, this method or this representation is more suitable than the magnitude angle form. Now let's try to plot the now what is your step 3? Now you're okay, that was actually your step 2, right? So okay, now step 3 is to draw the S-plane, right? Is to draw the S-plane, okay, or the S contour. Now what is your S contour? So first of all, you must look at this G of S, H of S, and it is not a the type. This one is a type 0 system, right? Since it is a type 0 system, you can go for what? Since it is a type 0 system, you don't have to exclude any points. That means you need to consider the whole of this right half plane, S plane, right? So if you do that, you can segmentize as OAB in the direction shown, right? So this is the direction. So the segments are one is OA, right? OA means as omega varies from 0 to infinity plus infinity, right? And then next is AB, which is actually a big circle, okay? Big circle R e raised to J, it is minus theta, right? Because it is an anti-clockwise direction, so it is e raised to minus j theta. So I have already told you. So in all these cases, as well as in root locus, we take clockwise in the negative direction and anti-clockwise in the positive direction, except in the encirclement, and we will talk about more in this problem. We will have to encounter such a situation here. So this will be AB is nothing but it is limit r tends to infinity r e raised to minus j theta. It refers to an anti-clockwise it refers to a clockwise semi circle, right? Okay, so this refers to a semicircle. Now you have one more segment which is actually BO, and BO is nothing but it is the mirror image of OA. You don't have to worry about BO. Once if you get OA correctly, then what you need to do is you just need to draw its mirror image. Okay, so and that omega varies from, the variation is from omega, as omega varies from minus infinity, this is the point minus infinity to 0. Okay, so this is the variation of omega. So we have got 3 segments and you need to map this. That's your step 3. Okay, so so that's the next step, that is mapping this S segments into your f of j omega plane. Okay, so by mapping, what you do is we will be substituting the each values at each point in this equation, which is in the Cartesian representation or a rectangular representation. So we are going to plot some values of omega, right, and f of j omega. Okay, so first of all, I am going to put 0. Now let us see what happens when I put a is equal to 0. You need to be very careful regarding the signs. That's very important. So when you put 0, right? So when you put 0, what you will be getting is, okay, right? Okay, so when you put 0, okay, what happens is this term becomes equal to 0. That means it is minus 1.25 divided by 0.25 into 4. This becomes 0, this becomes 0. So this is 0.25, minus 1.25, 1.25. Okay, then, okay, 1.25. Then when you put omega is equal to 0, of course, when you put omega is equal to 0, this becomes 0. And you have a tendency to put this is equal to 0. Okay, everywhere you need to put 0, right? Now, when you put this 0, normally we may have a tendency to ignore this negative sign. 0 minus a number is a negative number. This into 0, then that there must be a negative number, so that you need to consider that negative. Okay, so this is not available. This is not available in a magnitude polar plot. That's why I told you to use this method, so that if you are not considering this minus 1, then it will be minus j0, which is going to be a different result. So you need to consider this. Okay, when 0 is number, so this is a small number minus a big number, meaning this quantity has to be negative. So this negative, so anyway we know that the overall value is going to be 0, but there is a negative j0 point, so this is minus j0. Okay, so we will have to consider that, because what we do is, this is j0 plus, this point is said to be j0 plus to j infinity plus, this is j infinity minus j0 minus. So we need to consider that sign, so that you will get this as okay, I'll be rewriting this. Okay, omega and f of j omega. Okay, so when you put omega is equal to 0, what you get is minus 1.25, right, plus this minus, and this minus gets, so this becomes plus j0. Okay, so that's it. That's the first point. Now I'm going to put some space here. Okay, Now let us see what happens when omega becomes infinity. Okay, now when omega becomes infinity, what you need to do is you need to ignore these terms. This is how you need to substitute omega. So comparing this, omega is a very high value, so you can ignore this point. Okay, you can ignore this one, right? Okay, you can ignore this. So this value is going to be, so I'll be rewriting here, this value is going to be minus 1.25, okay, into it has to be a practice like this. This is the way, because why we are doing is, in this case there is no problem. Sometimes if there would have been a minus sign, we need to preserve that, then that minus sign is going to affect the result. So in this, so it is better always to do like this. So this will be minus 1.25 by omega square plus omega square into omega square, right? So all this, so the real term, what you're going to get, the real term is this omega square and omega square get cancelled, and then you substitute omega is equal to infinity, so that you will get minus 0. So the point is minus 0, the real term. What about the imaginary term? The imaginary term also, you have a minus sign already there, 1.25, okay, j omega into, what is this, omega square minus 0.5, so this can be neglected, so you will be getting an omega square in the numerator, then these three can be cancelled, so this will be omega raised to 4, so this omega cube and this will go, okay, so this will be minus 1.25 j by omega raised to omega square. So what will happen at infinity? This becomes minus j0. So the point is minus 0 minus j0. Okay, right? Now let's try to draw the Nyquist diagram. Okay, for that I am considering a complex plane with the, you must represent like this, f of j omega. Okay, we have already assigned this f of j omega to be this function. So real of f of j omega and imaginary of f of j omega. You need to show this point. Okay, now let's try to draw this. So we got actually 2 points corresponding to omega. So what we are doing is we are actually plotting or mapping this segment OA. That is, those are the 2 points of O and A. And we got your f of j omega as minus 1.25 plus j0. Okay, anyway, this is minus 1.25 means this comes around over here, right? So okay, let it be 1, let it be 2, so this must come over here, right? So this is a point, okay, so this is a point corresponding to, this is actually minus 1.25. So this is your minus 1 point, which is very important, right? Okay, and this is minus 2. Okay, now if I am going to plot this, if I am going to start plotting, okay, right? So okay, now the problem with this is, say, once it is minus 1.25 plus j0. So what is the meaning of plus j0? Plus j0 is always having, this is having a tendency to go upwards. If it would have been minus j0, then it should come down. That's why I told you, say suppose, imagine that you simply put omega is equal to 0, and if you are not considering this minus sign, it will be treated as minus j0. Okay, and the graph would have gone like this. But actually the graph should go in this way. It is because of this plus j0. Hope you understood. If it would have been minus j0, it will be starting from the same point but to the downward. So anyway, we know that as omega increases, this is going to, okay, this point starts to grow in the second quadrant. Am I right? So this is first, second, third and fourth. So definitely it will be going in this way. It will start like this. Now coming to minus 0 minus j0. So at infinity, what happens is it is minus 0 minus j0. Can you say in which quadrant it is? Okay, so I'll just write it for you. Say if it would have been plus 0 plus j0, this is your quadrant. Okay, so that means the terminating point will be coming through this quadrant. Now if a particular termination comes over this region, the second quadrant, this would have been minus 0 plus j0, right? Now if it goes in this way, this will be minus 0 minus j0. What about this? This is plus 0 plus j minus j0, right? So by this you can identify the quadrant. So actually this plot or the Nyquist diagram starts in the second quadrant, and we know that at infinity what happens is it comes over this region. Okay, now the next point is, okay, now that means we found we have got an idea that this particular Nyquist plot starts from here, and it arrives at this point. Now the question is, sometimes you can think in you have, or you may be thinking of two options, right, to reach that. So I'll be showing you the two options. Say sometimes you can think of having a plot something like this. It can come all over this region and come over here, or there is a tendency of coming in this way. These are the two options. Now how will you select, how will you select this path? It can go in this way or in this way. Okay, now let us see at which frequency this will be crossing this, right? So anyway, so in order to reach this, it has to cross either the negative real axis or the positive real axis. Now when this contour moves in the reaches or intersect the real axis, be it a negative side or positive side, what happens to the imaginary term? The imaginary term is 0. So this is the advantage of representing it in a, so what happens when an imaginary term, the imaginary term becomes 0? That is omega into omega square minus 0.5, that is 1.25. This term, the whole divided by the denominator. So when it is equated to 0, this denominator has no value. So that means this numerator can be 0. That means omega 0 minus 0.5 can be 0, right? Or omega can be root of 0.5, right? So omega can be root of 0.5. Now at this point we can evaluate the value of this real term. Okay, now if this real term at this frequency is a negative thing, then you can say that it will travel in this path. And if that real term is positive, then you will have to believe that this has to go in this way, right? So let us see that. So what happens at omega is equal to infinity is, root 0.5. Let us see whether there is any sign change. No sign change here, no sign change here. When you comes up here, this will be root of 0.5 means it is 0.5 into 2.5, some value plus 1, some positive value into a negative value. Still you can see that the real term is going to be negative. So meaning, what is the meaning of that? That means this particular, as omega increases, it won't be tracing this path. It will be tracing a path, okay, and it will be reaching somewhere over here. So in order to represent that point, you can find out that real term. How will you find out that real term? Just by putting omega is equal to root 0.5. So you will get the real term as 0.825. Okay, now from where will you, so it will be minus 0.25. there is a negative sign, minus 0.25. So okay, so if this is minus 0.5, it will be coming somewhere over here. So that means this plot will be traveling in this way, right? Okay, and it will be reaching like this. So this is the way. So you just need a rough figure, that's all. Okay, now what is the direction? So this is actually, look at this. So okay, so look at this. This is actually the omega corresponding to 0 plus. This point is corresponding to omega is equal to 0 minus. Infinity plus, right? So that is as you mapped from O to A, that is OA is the direction. So that means this has to be direction. Okay. Now what must be the next point? Next point is you need to plot AB, right? You need to plot this big circle. Now how will you plot this big circle? The big circle is mapped as we have studied in the previous equation. That is, you need to start with the g of s h of s, right? G of s h of s is equal to 1.25 into r e raised to put s is equal to, so that's it, put s is equal to limit r tends to infinity, that big circle equation, e raised to minus j theta. Okay, we have already identified this. Put this value into the s of this g of s h of s. So we will get this equation as, so this is 1.25 into r e raised to minus j theta, limit r tends to infinity, okay, plus 1 divided by, again you have r e raised to minus j theta, limit r tends to infinity, plus 0.5 into limit r tends to infinity, r e raised to minus j theta minus 2. Okay, so what happens? So you know that this is infinity, so in comparison to this you can neglect this 1, you can neglect this 2, neglect this 0.5, so that this becomes 1.25 into, okay, you can later on you can apply r tends to infinity. Okay, so this will be r into e raised to minus j theta divided by, you have an r into r, so that will be r square into e raised to minus 2j theta, right? This is this r e raised to j theta into, okay, so you can have the cancellation. So what will be now after that, if you apply infinity, you will be getting this as 0 into, that is 1.25 divided by infinity, that is 0 into e raised to minus j theta. So this becomes e raised to minus j theta plus 2 j theta, or this becomes e raised to plus j theta. So this big circle reduces to, normally it will be like that, this big circle reduces to a point at this origin. Okay, so this has to be the continuation, right? After this A, then comes this big circle, infinity plus to infinity minus, that reduces to 0. So if it requires to go in this direction, if you assume a circle, semicircle like this, if it requires to continue in this direction, it has to be an anti-clockwise direction, and that's what this equation suggests. So you don't have to worry about that. Now after this, how will you plot BO? What is BO? BO is nothing but, BO again starts from here, right? Now BO is nothing but, it is the mirror image. Mirror image, you need to draw it as a dotted lines like this. Okay, so you'll be getting a graph like this. So this must be your infinity minus, and this is 0 minus. Okay, so this is how things are going. Okay, so this is what is called as a Nyquist plot or Nyquist diagram, right? Now in order to draw this in a plain paper, you need to represent this in a rectangular form. Okay, so my suggestion is, whether it is a stable system or unstable, whatever it is, you may please follow this method. Okay, that will be nice. That's the thing. And if you are asked to draw in a polar form, you need to go in the other way around. Okay, that will be more easy and comfortable. Okay, now anyway, you don't have to think about that. I mean, normally I haven't seen yet a question like that to specifically asked to draw in a polar plot. Okay, polar graph sheet. Okay, so you don't have to worry about that. Now if time permits, we will be seeing all such things later. Anyway, so this is BO. BO is the mirror image of AB, and I have drawn this. Now what's your next step? Next step is to find out the encirclements. Now next step is to find out the encirclements. Now how will you calculate the encirclement? Now which is the point of encirclement which is to be considered? This is minus 1 plus j0, right? So where is it? This is the minus 1 plus the j0 point. Now our considered point is, this is minus 1, right? Okay, this is minus 1 plus j0 point, right? So let us see how many encirclements it has. So when you start, how will you calculate the encirclement? Start from a point and reach, how you reach that, that's it, number one encirclement. So you have one, and without repeating a step, it will reach over here. So you have an encirclement. Now encirclement around that point is clockwise. Do remember, very important, the encirclement has to be taken as -1 because it is a clockwise rotation. Sorry, it is a clockwise, so you need to take it as positive, right? Clockwise rotation, right? So this is a clockwise rotation, so you need to take this as positive. Do remember that. That's very, very, very important. Okay, now, okay, so this is n is equal to +1, meaning this is a clockwise rotation. So in this encirclement only, we have this notion of taking clockwise direction as positive. So n is equal to z plus minus p plus. Okay, now if you can go in the other way around. In order to avoid confusion, you can also consider the anti-clockwise as positive, provided you need to take the expression as p minus z plus. No, you don't have to confuse that. So far we started studying like this. I should have done in the other way around, but anyway, since we have started like this, you may just stick on to this. The only thing that you need to understand is in the encirclement case only, you will be considering the clockwise as positive, provided your encirclement equation is z plus minus p plus. Okay, now you have already found out what is your p plus. What is your p plus? P plus is equal to 1, right? So substituting that, you will get this as z plus minus 1. Okay, -1 is equal to what? It is equal to +1. So what is your z plus 1? Z plus 1 is equal to 2. Now applying the Nyquist criterion, what does the Nyquist stability criterion states? For a system to be stable, this z plus has to be equal to 0. But since it has got 2, z plus is 2, meaning it has got 2 right half poles in the S-plane. Okay, so of the characteristic equation 1 plus GSHS. That is what this suggests. Okay, so it will be having 2 right half poles in the S-plane for 1 plus GSHS, which makes the system unstable. Okay, now we have seen that for k is equal to 1.25, the system is an unstable system, right? We have seen that this is z plus is equal to 2, or it refers to 2 RH poles in the S-plane in the plane of 1 plus GSHS. Now, okay, you may try this problem, try the same problem. Okay, do this as a homework, where GSHS is equal to k into the same problem, S plus 0.5 into S minus 0.2, right? Now we have done this problem for k is equal to 1.25, and now what I'm asking is change the value to 2.5. So okay, so you may obtain the Nyquist plot, and thereby apply the Nyquist criterion to see whether the system is stable or not. Okay, so do this as a homework, and probably next day, tomorrow, we will be having a Google Meet session. So there I'll be asking the question regarding this. So make sure that you do this problem today itself. Okay.